Hey everyone, how's it going? And welcome to this talk on customizing performance metrics in the Unity Profiler. My name's Andy, and I'm a software engineer at Unity working on performance profiling tools. To give you an idea of what that involves, our team most recently built the new memory profiler package available in the upcoming Unity 2022 release. But we also maintain the Unity Profiler, which will be the subject of this talk. In Unity 2021 LTS, there are a range of ways the profiler can be customized with your own performance data and visualization. This image provides an example of what you can achieve and what we'll cover today. It shows a custom profiler module that ships with the Dots Entities package. The developers of this package are using this custom profiler module to surface performance information related to their package. They've added their own profiler counters to track key performance metrics, which you can see in the module's chart at the top. And they've also implemented a custom UI for their module's details view, which is the area underneath the chart. And they've used this details view to provide additional data to help users investigate any performance issues. This all combines to help users of the entities package to more easily monitor, understand, and optimize their performance. And this hopefully illustrates why customizing the profiler is valuable and how it can help you to surface performance metrics related to your own systems to optimize their performance. So in this talk, we'll cover customizing the Unity profiler in three aspects: profiler markers, profiler counters, and profiler modules. And we'll see exactly what these are in more detail as we cover them. But firstly, a very brief introduction to the Unity Profiler. For anyone who isn't familiar with the tool, the Unity Profiler gives you detailed performance information about your Unity application. It helps you to monitor the performance of your game, to diagnose performance issues, and to pinpoint where optimizations might be made. You can see in the image on the right here that the Unity Profiler includes a large amount of built-in performance metrics and data covering many aspects of the engine. Customizing the Unity Profiler, though, as we just saw, helps you to expose the performance metrics of your own systems to help you better monitor their performance in your game. Now, the profiler marker and profiler counter APIs that we'll cover today require the profiling.core package to be installed. This is a fully released package in 2021 LTS, and you can add the package by name from the package manager. So let's start by looking at profiler markers in the Unity Profiler. Profiler markers are used to outline resource-intensive blocks of scripting code. They will measure the code block's execution time, which can help you identify long-running tasks or bottlenecks. Markers are displayed in the profiler window's timeline and hierarchy views, and in combination with other markers, they offer a structural overview of your game's code, which you can see in the image of the timeline on the right here. This can all help you to understand where your execution time is being spent. By default, Unity includes markers for a large amount of engine code. Adding your own markers allows you to both measure the execution time of your code, as well as to surface these timings in the profiler's timeline and hierarchy visualizations. So let's look at measuring some code with the profiler marker. In this simple example, we have a single method, simulate, that we'll imagine does some expensive simulation work, and therefore we want to measure. We first define a new profiler marker, passing in the marker's name to the constructor, which is the name that will be shown in the profiler. Then we use the profiler marker's auto method with a using statement around the code that we want to profile. And that's it. Now our simulate code will be measured and displayed in the profiler. So here's how that looks in the profiler. On the left, we have the timeline, and you can see our custom marker, mysystem.simulate, which took 0.27 milliseconds in this case. You can also see our custom markers shown in the hierarchy view on the right. And you might also notice that we can infer information about our game code structure. For example, you can see that I called our simulate method from a mono behavior update by looking at its parent marker. An alternative approach to using the auto method that we just saw is to use a marker's begin and end methods directly, again, wrapping the code we want to measure like this. The benefit of using the auto approach from before is that our marker is always ended when the scope exits. Compare this with the begin and end approach here. If an exception was thrown by our simulation code, then our call to profiler marker.end would never be reached. However, the trade-off with using auto is that it cannot be compiled out in release builds, whereas this explicit begin-end approach shown here can be for zero overhead in release builds. Now, in release builds, auto does return null, so the overhead there is minimal, but non-zero. You can also add metadata to a profiler marker, which can be useful for providing additional context to your marker. For example, here we're adding the number of objects that were simulated as metadata to our simulate marker from before, which might help us to identify why our simulate code took longer. You can see that we're now using the generic profiler marker where we specify the type of the metadata, in our case, an integer. We also provide the metadata's name, object count, as the second constructor argument. Then we simply pass our metadata's value to the marker's auto method. And now when we select our marker in the timeline, which you can see on the right, the metadata is shown along with the name that we specified. So that was a very quick tour of measuring your code with profiler markers. Next, we'll look at profiler counters. Profiler counters track, measure, or count metrics in your game that are useful for performance analysis purposes. For example, a counter could track the number of instances of a prefab, or the number of bytes of memory used, or the time taken to execute some code. Counters are displayed in the profiler window's charts, as shown on the right here. This is useful for monitoring the value over time and correlating it with other counters or activity. Counters can also be queried from script in development builds, and you might do this to display some key performance metrics directly in-game during testing. As with markers, Unity includes a range of counters for engine features by default. By adding your own counters, you can expose performance metrics of your own systems directly in the profiler window, which, as we saw earlier, can aid in better understanding its performance impact. So let's see how to add our own profiler counter. Here we have a game scene in which we have creatures that are spawning as the player progresses through the level. We'll add a counter to track the total number of active creatures in the scene. We declare a new profiler counter using the type profiler counter value, and in this case specifying integer as our counter's data type. We specify the name of the counter, again the name that will be displayed in the profiler, and a data unit. In our case we can specify count, but other available units include time, bytes, percentage, and hertz. Then we simply need to update our counter's value to reflect the number of active creatures at any given time. To do this, we can create a simple mono behavior that we attach to the creature prefab and use the onEnable and onDisable callbacks to increment and decrement the counter's value accordingly. So we now have a profiler counter tracking the number of active creatures in our scene. So how can we see it in the profiler? One way to see our counter quickly in the profiler window is to use the module editor. The module editor allows you to quickly create profiler modules for your own use. As we saw at the start of the talk, a profiler module displays a chart of counters, so we can use one to show our new creature count. It's worth emphasizing that the module editor adds modules locally to your editor, which means they aren't available for other project users or team members. So let's use the module editor to quickly create a profiler module that can display our new creature count. You can access the module editor from the settings cog within the profiler modules dropdown in the top left of the profiler window here. Then in the module editor, we can create a new module by clicking the Add button in the bottom left, and we can use the list of available counters on the right to add counters to our new module. In our case, we add our creature count. It's worth noting that you need to have captured some profiler data that includes your new counter for it to be present in this list of available counters. So after I added the counter on the previous slide, I entered play mode with the profiler recording and captured some data that included the new counter. And after selecting Save Changes in the bottom right, our module is added and our creature count is displayed in the profiler window. And we can see its value changing over time as we play through our level. Profiler counters can also be monitored from script in development builds without the profiler attached. And you might do this to display some key performance metrics directly in-game during testing. Now, this includes built-in counters, not just your own custom counters, meaning you can mix built-in metrics with your own. So let's look at an example of this. This script shows how to update an in-game label with the current values of two counters. We read profiler counters at runtime with a profiler recorder object. So here in onEnable, we use profiler recorder's start new method to construct a profiler recorder object and start monitoring the specified counter. Then in our update method, we retrieve the counter's last value from the corresponding profiler recorder and update a label's text. And finally, in our onDisable method, we dispose both of our profiler recorder objects to free unmanaged resources associated with them. Here is that script running in our game. You can see our UI in the bottom left, displaying current values for both of the counters that we've specified. And hopefully you can also see how this might be useful for monitoring key performance metrics directly in-game during testing. That covers adding your own profiler counters to the Unity profiler, as well as using the module editor and displaying your counters in-game. Next, let's look at the last topic of profiler modules. A profiler module presents performance information in the profiler window for a specific area or workflow. For example, our built-in modules include memory, rendering, and audio, and we saw the structural changes module earlier specific to the dots entities package. Now, a profiler module displays two things: a chart of profiler counters showing their values over time, which we've just seen, and upon selection of that chart, a details view underneath that, providing additional information for the selected frame. To illustrate that with an example, this is the built-in memory module. It uses its chart view to show 7 profiler counters relating to memory usage, allowing you to see these memory trends over time. And it uses its details view to show the distribution of memory in the selected frame. In Unity 2021 LTS, the profiler window can be customized with your own profiler modules. In combination with profiler counters, this enables you to present the performance metrics of your own systems directly in the profiler window. We also allow for custom visualization. We also allow for custom visualization in your module's details view, which allows you to present entirely bespoke visualizations of your performance data. Custom profiler modules are available for all users of the Unity project or package to which they're added. For example, say you have some system in your game and you've added some profiler counters to track some key performance metrics. You could now add a profiler module to your project to show these metrics in the profiler, and all members of your team will see that module in the profiler window. Similarly, if you're a package developer, you can now add your own profiler module to your package, and your module will be available in the profiler window for any users who install your package. And I absolutely love this feature because it means asset store publishers can effectively distribute profiler modules with their products that help their users better monitor its performance impact. And I personally would have loved this feature in my time as an asset store publisher. So let's see how we can add a custom profiler module to a Unity project or package. For this example, we'll build on our creature count that we added earlier, and we'll add a module that shows two counters, the creature count, as well as the built-in counter called batches count from the rendering category. This will allow us to correlate the number of active creatures in our scene with the number of render batches that the renderer has to process. First, we define a subclass of profiler module in an editor folder in our project or package. Next, we attribute this class with the profiler module metadata attribute, and this is where we specify the name of the module as this will be displayed in the profiler window. And lastly, we specify the counters that we want the module to display in its chart to the base constructor. Note that these aren't references to the actual counters themselves. They are profiler counter descriptor structures, which describe our counter using its name and category. So if you add this script within an editor folder in your Unity project, the module will be available for all users of that project. And if you add it to your package, the module will become available for any projects that have added your package. So with that script in our project, the profiler window automatically updates to show our custom profiler module, as we can see here. And you can see both counters that we specified, creature count and batches count, being graphed over time in our module's chart view. This allows us to both monitor their values, so we could see a sudden spike, for example, as well as to correlate between the two and see how one might be affecting the other if necessary. So that's how we can add a custom profiler module to the profiler window for all users of a project or package. Now, you'll notice here that our module's details view, that's the area underneath the chart, by default shows a list of the module's counters and their values in the selected frame. What we'll look at next is how we can customize this details view. You can provide a completely custom details view for your profiler module. This allows you to draw your own user interface using UI Toolkit, which is an opportunity to present a custom visualization of your performance data for the selected frame. To give you an idea of the flexibility available, we saw the structural changes module earlier where the developers were displaying a tree view or hierarchy-like UI in their details view. Here is a second example taken from the adaptive performance package. You can see how the developers of that package have presented their performance data in a very different way and in a way that helps them to convey their performance story effectively. So let's see how to build a custom details view to tell your module's performance story. A module can optionally provide a custom details view if it wants to override the default. It does this by overriding the method createDetailsViewController, in which it needs to return a details view controller object. This view controller object is responsible for creating the details view, which is just a visual element hierarchy, and managing any behavior or interaction within the view. Unity will request your details view from your module using this method when it needs to be shown. So to do this, we start by creating a view controller, which we do by subclassing the profiler module view controller class. The base class constructor expects the profiler window to be passed to it. So we have a constructor that passes one through, and we'll see a use case for this a bit later. Now, we said in the previous slide that the view controller object is responsible for creating the details view. We do this by overriding its createView method, where we build our details view. We've done exactly that here to build a very simple view to demonstrate, which is just a single label with some inline styles. And now we just need to hook this view controller up to our profiler module. As mentioned before, we do this by overriding the createDetailsViewController method in our module. And in it, we return a new instance of the view controller that we just created, passing in the module's reference to the profiler window. And here you can see the custom details view that we just made, containing a single label. Hopefully, this illustrates the flexibility you have to provide any appropriate visual element hierarchy here, and ultimately to draw the visualization that best conveys the story of your data. Now, this example is very simple for demonstration purposes. So before we wrap up, let's have a look at 3 additional tips to help you when building your custom details view. The first is that I recommend using UI Toolkit's UXML and USS asset types to define your details view. Now, you can build your view entirely in code, as we just did. However, using UXML and USS allows you to firstly use UI Builder, which gives you a visual interface to build your UI and means other team members without coding skills can make styling changes. And secondly, even if you don't use UI Builder, I find it makes iterating on your design much quicker because you can make layout and styling changes without invoking a domain reload. If you take that approach, this is an example of how your create view method might look. We use the asset database to load a UXML asset and instantiate its view hierarchy, returning the root visual element as our view. The second tip is how to respond to frame selection. We covered earlier how the module's details view is intended to show more information related to the selected frame. Therefore, when the user changes the selected frame, you need to update your details view to reflect that. And this is where our profiler window reference on the view controller comes in handy, because we can use its selected frame index changed event to be notified of this and update our UI accordingly. That's exactly what we're doing here in this example. By subscribing to the selected frame index changed event in our view controller's constructor, we can then refresh our UI in the handler. Notice how we are unsubscribing from the event in the view controller's dispose method. So a view controller is disposed when its view is no longer needed, such as when another module is selected or the profiler window is closed. So you can use this dispose method for any cleanup of your view controller, as we do here to unsubscribe from the event. And finally, let's see how to read counters in the captured profiler data, which you'll of course need to do to display them in your details view. Note that this is different from reading counters at runtime with profiler recorder objects that we saw earlier, as here we're reading our counters from the captured profiler data. The first way you can do this is with the get formatted counter value method on the profiler driver class, as shown here. This will return you the specified counter's value in a pre-formatted string, taking into account its unit. The second way is to use the get counter values batch method, also on the profiler driver class, with a buffer size of 1, like this. This will return you the counter's value as a float. And a third way is to obtain the selected frame's data using the get raw frame data view method, which we do in line 2 here. Then we can use one of the get counter value method variants on the returned frame data, as you can see here in line 10. Notice that your frame data needs to be disposed after use, which we do in this example with a using declaration statement. So it will be disposed when the scope exits. So that covers adding your own profiler modules to the Unity profiler, and it also concludes our talk. To recap, we covered customizing the profiler in 3 aspects. We saw how to measure our code with profiler markers and pass custom metadata to them. Then we covered how to add a profiler counter to track a metric in our game, how to see this counter in the profiler using the module editor, and how to read its value at runtime in development builds to build an in-game UI for testing. And then we saw how to add our own profiler module for all users of a Unity project or package, as well as how to draw a custom details view for it. And over the course of the talk, we saw 2 examples of packages that are already using these APIs to surface performance metrics to their users in the dots entities and adaptive performance packages. Hopefully, that gives you some ideas and inspiration for how you might customize the profiler to tell your performance story. For more information on what we've covered today, please visit the blog post linked here, which also contains links to all the relevant documentation as well. Thanks for listening.